Talking about the recommender system, a survey. I collected the state of art recommender system technology and the architect together with some recent technology in recommender system. So uh, there are usually two types of recommender system. One is the content-based filtering, another is a collaborative filtering. The content-based filtering is a basic theory in recommender system that mostly use the content. For example, when we try to recommend movie, the movie itself has a content like is that action movie or is that a romantic movie or for example, there's maybe a category itself is a content or the movie description, etc. This is the other content itself. So based on the content, we can do a lot of filtering without knowing, without having the massive user. For the collaboration filtering, there's another situation when we have a massive user base. I have a lot of users have a base logs. We can use those user history to do the collaboration filtering. How it works is most like how I get a recommendation from my friends about what's can recommend me a movie, so my friend know what's my favorite and they recommend me some of the movie, even though I did not really watch a lot of movie on Netflix. Depend on the underlying data. There are another two types of recommender system. One is the model based. This actually is the most common one. Another is the memory based. The memory based is mostly based on the history you watch a movie um, to recommend you a new movie. So memory based usually have kind of more use more raw data to do recommender system. Some of the common use cases here, including like movie recommendation, it's like Netflix, music recommendation, Pandora, Last FM, etc. For the Amazon is a very popular product recommender system. They are also one of the pioneer in the recommender system. For the news recommender system, like the Google News or the Toutiao in China, um, as we open our LinkedIn, we will see they can recommend us a lot of people you may want to follow, or you may be interested in this person. That is kind of a people recommendation. That's also another very interesting part. Um, the system architect for the recommender system. This is a very interesting one. I mean, this one is mostly from Netflix, but they give us very typical architect. What's the components usually we have in the recommender system? There are few key components. The offline part mostly do the offline model training, and the nearline, and this usually means some requirement which we do not need a response in milliseconds, but we want to have it quite real time. But we cannot delay for a few hours, but I want to delay like few minutes, maybe should be okay. For example, like the trending in the Twitter, what we usually see. For the online, usually means user send a request and you want to get a response immediately. Like if I open the Twitter homepage, type twitter.com, I need to get my homepage result immediately. And all the feeds and also my friend is posting. So this is real time. So for the models in this part and also the logic in this part usually quite simple, so that they can get a response immediately, or even there are some of the complex computation they may be pre-calculated so that we can get a result in real time. So we can talk more details in the each part of the system. Um, we can talk about from the online part, like for example, the user send a request to the server, and the server side, the online part, run the real-time prediction or real-time recommendation API to use the pre-calculated result of the real-time algorithm to send the user the recommended result, usually with some kind of a re-ranking to hybrid the source from different recommendation algorithm. For example, if I open tweet, I may have like the hot news, the hot tweets, the trending tweets, the tweet from my friends, and some tweet maybe some with kind of a relevance, maybe the kind of a recommended tweets. I mean that's maybe different cases in different recommender system, but usually you have some quick ranking algorithm before we push to the user. After user get the recommended results, either tweet or movie or whatever, I may click OK, play the movie, and maybe I rate the movie as good or bad, 1 star or 5 star. I may browse some of the movie to see if I really interested. So this user activity log will go back send to the backend to the server side. Usually it usually can send to the nearline and both the offline part. For the offline part, they get the log, and they can for this user activity they continue and try to understand the activity by extracting what the activity it means behind. For example, I play the movie that is a very strong feedback says that movie is one of my interests, and if that's from the that movie actually from the recommender system, I mean that's a recommended movie, that means the movie is well recommended. That means the recommender system works good. If not, that maybe means the recommendation result is not good because the user did not really click the recommendation result as I said. So that's called feedback. So with uh, either way, either is the first time user click it, or either that is from the user recommendation, the log will all go to the offline, and uh, the model training will take the offline data, use that to like extract the metadata from the movie which is I viewed. For example, the category, the syntamic analysis, etc., or the tag analysis to understand the user activity and update the models. That usually can come from the offline training because to understand my behavior, the system actually do not need to get me my profile updated every minute. They probably, for example, my preference may not change every minute. I may change every few months, even longer. So that daily or even weekly computation should be good enough. That's why it goes to offline computation. So for the nearline computation, one example is for the user activity event. The event distribution can distribute the event to the user event queue. There comes to be they can do some um, nearline computation, for example, like the training. Say what's the latest trending movie, what's the latest trending tweet. That usually, for example, how it works is there are usually some real-time streaming algorithm and the system running. For example, they can be run some algorithm inside the Spark to analyze the trending topic Twitter, or analyze do some sentiment analysis for a given topic. And then after we get the result, we can save a result to the database or cache, etc. I mean, the nearline computation can also have other computation. For example, we can update the user feed, but maybe in a near real-time computation, we can do the computation and then push back to the hard storage, so that when the user refresh it, you can also get the result, update the result. And yeah, with that three different components together with the offline, which is do the model training, nearline do the near real-time computation, and eventually the most user interaction comes from the online part. Let's just system architect about how the system work. We can talk about a few detailed algorithms. For example, the collaboration filter. This is the best field for the problem. We have a lot of user visit history, different users, um, but we lack of the detail at item for the item, or lack of the feature extraction for the item of the internet. So what that means is we want to try to build a model from the user past behavior that is not necessarily from the features between the item and the user. As the example I gave, it's more like I do not really have enough understanding from this new, for example, this is a new user, and there's a lot of items in the database. The system actually do not know how to do the recommendation for him or her, and then the system try to find the people which are similar to these people, to this person, so that they can find their favorites, their friends' favorite movies, and recommend to this user. So that is usually also solve the problem as a cold start problem. Uh, the item recommendation, that is a very straightforward one. So it's like I know what you are opening, like for the on the Amazon, you are trying to buy a Coca-Cola. On that page, around the Coca-Cola, we say there are some other similar items like Pepsi. That is item-to-item recommendation. That is straightforward. We can simply compare the the features between each item to calculate what's the closest item for this item, so that we can get a similar item to recommend to the user. And that is also works good if we do not have um, too much info from the user side. So the user item recommendation, and that is similar as the item recommendation. That is we are not do the calculate the similarity between each item, but instead based on the user activity, we have built a user profile, which usually have similar features from each item. For example, from the item side, we have an array and a feature to understand which category this item belongs to. For the user side, the user visits like 10 different movies. For each of movies, they have their own category array, and we can do the calculation by simply, for example, sum up all the features from those 10 movies the user visited. Then we build another user profile based on the user activity log. So then when we do the recommendation, we can simply calculate the similarity between the user and the item. So that comes to be a user item recommendation. That is also another straightforward calculation. And the user recommendation, that is actually what it means, the collaboration filtering. So based on the user similarity, we can recommend an item which is actually from your closest friend. What I talk about that is some very basic recommender technology. There are some other topics, for example, the training. As I mentioned, that the training is a very interesting topic because that's usually we use some other series. We need for the training, it's more real time and dynamic, and the time is another important factor for the training. How we do the, for example, in this example, on the right side, that's from the Twitch. I just take a screenshot from my Twitter. So you can see the training. The training can be a training news, a training topic, etc. But for the training, how we do the prediction, we can have a lot of different algorithms, but the basic idea is, first, if any topic can show as the training here, we first want to have some threshold. If for example, the tweet is only viewed by first 10 people, and then it go to viewed by 200 people, that's usually not become a training because that is not hot enough. We still want to have set a little bit threshold. For example, if we have at least 10,000 views, we want to start to treat it, apply the training algorithm to see if we want to do the training for this news. When we do the training, we may usually for example, use a time window. Say for each of the minutes, how much the user views increase for each of the time window. If they keep increase, for example, more than half an hour or after 1 hour, the trend is continue increase in a higher rate, or we can match it to a pattern. We want to identify this as a training. Um, for the training, we can also combine with a personalized recommendation. For example, for the trainings, we can put maybe in the backend we have a thousand of training topics. For the training topic that I deliver to this specific user, maybe I need some pick 10 of them. I probably need to think about how the training is, and also I need to consider what's the favorite of this user. So we need to do some other re-ranking for the training as well. There's another topic we need to consider is the novelty, or sometimes we call diversity. What that means is, for the recommender system, there's one key problem is when user visit one movie, based on the similarity, you want to recommend the user another movie that is mostly like similar to that movie, and the user may like it, continue to watch the movie we recommend, and then that also reinforce the learning algorithm. Say, yeah, the user like this type of movie, continue to recommend, and the user always gets a similar movie, and you're not actually learning new things. But that usually works in the real world. Um, but in another way, we want to create some novelty, because that is we the user like it. It does not mean the user do not like anything else. We may miss a lot of important interests from the user. We want to have some novelty, diversity. For example, we can randomly, one big theory, we can randomly pick some other, um, for example, different categories of movies, but mostly you can from the hot movies to recommend it to this user. Um, we can add some kind of a randomness, so that to make sure we are not always recommended the same result. Or we can, for the movies with similar category, we can also try to do some randomness and pick some of the result which is completely not in the our recommender result. This is very important part. There is another data flow of in this algorithm we call the feedback. The feedback is as I show in the architecture part. When we recommend some of the movie to the user, and the user may have some feedback, say, I recommend this movie. The user may click it or may not click it. That's a user feedback. That's actually implemented feedback. With this feedback, we can either evaluate the algorithm performance with some algorithm like for example, we can calculate the precision recall, or the NDCG. Those are the ways how we evaluate how accurate the recommender system is. Meanwhile, after we get those data, we can also improve the model with the user feedback. If we added the feedback into the system can become a kind of a closed loop system. So besides the traditional recommender system, we can also have some new deep learning approach in recent years there come a lot of new theory with that. For example, for the collaboration filtering, there's some neural collaboration filtering comes, and also like ALS, which is alternating least square, or XDeepFM, which is extreme deep factorization machine. That's some deep learning approach. Also, there comes another very useful theory, reinforcement learning for recommender system. How that works is a little bit similar as think about the feedback system. The user, when we recommend something, the user actually give us a feedback. It basically says I like it or do not like it, I recommend the result. That's a very important part of the theory for the reinforcement learning. So basically, for the reinforcement learning, there is some basic, very basic theory for reinforcement learning. Like if we try to train a helicopter, I mean like a toy helicopter to run in a lab. How we do reinforcement learning is we may use some algorithm to make the helicopter fly, but the helicopter can try to run by itself, and then for example, the helicopter may hit while he's flying, it may hit the wall or fall on the ground. That means it failed. I mean, if the helicopter, the algorithm know it's failed, so we try to at least you can automatically label this the this they can get a explicit labeling, and they can for the they know which action can lead to right, which action can lead to wrong, so that for the failures they can always reinforce, say we're not going to try these parts. For the success one, that means give them more confidence, say we will try this part. That's how the basic theory of the reinforcement learning work. There's some theory like Q learning, etc., to do the real reinforcement learning work. So if we look at the feedback system, they have similar type of data. So when we recommend something, it can be automatically labeled. I mean, the automatic means actually from the user manually, but from system wise, it's automatic. So that's some theory about how we can apply the reinforcement learning for the recommender system. There are some other evaluation metrics about how we evaluate the recommender system. One thing is we want to evaluate the rating. By the rating, the rating is like the user give a rating for recommender result, and then we also, from the recommender system side, we also predict a rating. That's how we recommend the result to the user. So we can use IMSE or I square or just MAE, or it's like explain the variance to evaluate the rating metrics. The ranking is another important part. It's like you want to put the result into one homepage for a user. We need to hybrid the result from different algorithms. We need some re-ranking, and for the re-ranking quality, we need also do the evaluation. Here we say we can use precision recall, or Those two methods we actually do not consider the order too much. But with another algorithm called NDCG, that one, when we do the evaluation, actually they consider the order of the recommended result. That's maybe a better way to do the evaluation. For some classification result from the recommended system, we can use some, for example, AUC, area under curve, or logistic loss as a log loss to evaluate the classification metrics. Yeah, there are some other topics we can cover. And one big problem is the sparsity. Um, the sparsity means, for example, in the e-commerce system, um, there's a long tail actually usually for the items. There are some hot items they sold a lot, but for majority of the item, and it's a very rare of the people actually buying those items. So that causes a long tail, and the long tail gives a lot of trouble to do the computation. For example, if we want to recommend an item for one user, we may want to recommend 50 item to this user, but in the backend we may have uh, maybe millions of items in the backend. We recommend the result to the user. We actually do not want to actually calculate all the millions of items and then recommend it to this user. Usually, for this type, we may need try to do the recognition, calculate the most similar ones from the hot items and not from the other items. That's how we solve the sparsity problem. There's another way how we do that is like we can hybrid the regular recommendation together with some randomness, or we call it novelty, to recommend the item to this user. This I mean, to add some randomness, that one hand is actually generate some solve the sparsity problem to do the calculation. In another hand, we from the like Amazon, from their side, they can also benefit for the item which is rarely bought by the user. We want to really understand if this item are really good or bad, so you can randomly generate some recommendation to the user, see if any user will like it. It's a little bit kind of marketing strategy. That's also is benefit to the user and also benefit to the sellers. Yeah, that's pretty much today about the recommender system. Thank you.